We will talk about functions in this chapter and then lay the groundwork in this section. A relation shows a connection between two sets. A function is a specific type of relation that matches every element in the first set to exactly one element in the second. If it is a function, then the first set is called the domain, and the second set is called the range. So first of all, we want to say, is this a function? Is every element in this first set matched to one element in the second set? And the answer is yes. This XS, extra small, goes to size, that's one spot. Red goes to color, that's red going to one place. Yellow goes to color, that's yellow going to one place. 45 going to number, that's 45 going one place. And A going to letter, that's A going one place. So yes, this is a function. So what's the domain? The domain are the elements that are in the first set. So we'd say the domain is in a set, so that's the squirrely brace is what it's called. We would just list those items or those elements. So this is the domain. This over here where it goes to is the range. Again, the range is a set, so we have our bracket, our brace, and then we would just list those elements. Okay, so then this one says the same thing. Is this a function? So we have 172 going to 20, that's one place. 207 going to 21, that's one place. 219 is going to 18 though, and 17. So 219 is going two places. That means it is not a function. A function can have every element in this first set goes to one element in the second set. If it's not a function, then we don't have a domain or range. So let's look at this. This is the same idea, but it's written in a little bit different format. This is really saying that this -2 has an arrow to this 2. So we could write this like we did before. We could put the -2 and then the 2. And then in this next pair, we'd have -8 is going to 8. In the next pair, we'd have -6 is going to 6. Here we'd have -1 is going to -1. And here we'd have 8 is going to 8. So you can see every element in this first set is going to one element in the second set. So yes, it's a function. And our domain would be the elements that are in this first set. -2, -8, -6, -1, and 8. And our range would be the elements that are in the second set. 2, 8, 6, -1, and 8. Now you see how this 8 is listed here twice. We don't normally write that twice. So I would really just write it like that. And really over here we should have not written this 8 a second time, but just had the arrow going like that. Again, that's okay. It's just everything over here is going to one number on the right. So here's another example. Here we have 8 going to -1, -6 going to 7, -7 going to -2. Then here I have 8 going to -3. Well, I already have 8 written, and so here I need it to go to -3. So here's the problem, is now this 8 is going to two different places, and that means it's not a function. Again, we don't have a domain or range if it's not a function. On a graph, we use the vertical line test to see if the graph is a function. If a vertical line crosses the graph more than once, the graph is not a function. So here the idea is if I draw a vertical line, straight up and down line, any place I want, it's only crossing that graph in one spot. So this is a function. However, here, if I draw a line here, it crosses a graph here and here. Or if I draw a line here, it crosses a graph here and here. This means it's not a function because the vertical line is crossing the graph in more than one place. Function notation. We write a function as in this format. We read a f of x. It means that we're putting x into a function named f. So in this function, we have f of x is equal to negative 4x minus 1. It's a little bit like having this machine. And whatever you put in, it does negative 4 times whatever that is, minus 1. When you turn the handle, it spits something out. So this is saying that I want to put 4 into this machine. So when you turn that handle, this machine says, okay, I'm going to take negative 4 times 4 minus 1. And I'm getting that from right here. This x represents the number that's being put into that spot. So negative 4 times 4 would be negative 16, minus 1 would be negative 17. So that's what's coming out of here, and that's our answer. So here I have g of z equals 4z plus 2. So here's how I normally do it. I do g, and then I leave parentheses with a big gap here, equals 4, and then instead of that z, I'm going to put parentheses with a gap there, plus 2. So instead of this z and instead of this z, I'm leaving a space. Now this over here tells me what I want to put into that space. It says put z plus 2 in that spot. So I want z plus 2 over here because that matches what they want me to find. But if I put it here, that means I also have to put it here. So this is the pattern of the machine, and z plus 2 is what we're putting into that machine. So then we'll simplify, we'll distribute, and we get 4z plus 8 plus 2, and we get 4z plus 10, and that's our answer. So we'll do the same thing here. So this is saying we want to find f of x minus f of 5. When we know f of x, it tells us that f of x is equal to 5x plus 4. So let's find f of 5. So f of 5, again, replaces this x with 5 and replaces this x with 5. So I have 5 times 5 is 25, plus 4 is 29. So now I can go over and I can do what they originally asked. They wanted f of x minus f of 5. So f of x was right here. That's 5x plus 4. It's a good idea to put it in parentheses, at least to start with. Minus f of 5 we found here was 29. So we'll simplify. 5x plus 4 minus 29 gives me 5x minus 25.